This presentation will look at energy sources and their classification. Energy, we have actually already defined as the ability to do work or cause matter to move or transform in some way. Energy comes in many different forms. Actually, energy comes in really one form, but we classify it in many different ways in terms of how we interpret what we're seeing. So we can classify all energy as one of two types, either kinetic or potential. Kinetic energy is the energy due to the motion of an object, whereas potential energy is due to the position of an object relative to some other object. We sometimes say that it's stored energy. Potential energy we can further subclassify into multiple types. I'm going to give 5 types today, and some of these are actually related to one another. First is chemical potential energy. With chemical potential energy, this is energy due to the positions of atoms relative to one another. So, for instance, if we have the water molecule H2O, and we have oxygen and hydrogen that are attracted to one another, and due to that attraction, they possess a type of energy known as chemical potential energy that's due to their attractions to one another. There's also some repulsion because, as you know from your physical science, both of these atoms, hydrogen and oxygen, have a nucleus with protons, and those protons repel one another, as well as the electrons of the two atoms repel one another also. So chemical potential energy is due to how close these objects are to one another, as well as the forces that exist between them when they are close together. Mechanical potential energy, which is spelled wrong. Potential energy is energy due to the arrangement of objects capable of storing energy, such as springs and rubber bands. You can stretch a spring, you can compress a spring, you can stretch a rubber band. When you stretch a rubber band, it's going to be storing energy, and of course it has the potential to pop back if you release it. A spring does the same thing. Some of them can be stretched out, some can be compressed. Either way, if you push or pull on it, it's going to be storing energy due to the work that you did on it as you stretched it or compressed it. We have nuclear potential energy as a third type. This is energy due to the relative positions of particles in the nucleus of an atom, such as protons and neutrons, but we can get further into that. That's not really part of this course, however. We have gravitational potential energy, which is energy due to the relative position of an object relative to the Earth itself, where the Earth is the second object. And then potential energy due to electrical potential energy is the energy due to the relative positions of charged objects, either electrons or protons. Generally speaking, potential energy is going to require pairs of things, forces between objects, in order to say that we have potential energy. Potential energy can exist on an object that's completely isolated from all other objects. Kinetic energy is the second major type, and we can further, again, subclassify it into 5 types. I'm going with Project Lead the Way's classification. This is not necessarily the way I would normally do it, but it works. So first of all, with kinetic, it's the energy that's from the motion of an object. There are 5 types. We have electrical energy, and this would be electrical kinetic energy or electrical energy. This is due to the movement of charged particles, primarily electrons, but we could also look at this as positive charges moving as well. Electrons are negative. We have radiant energy, which would be energy due to the movement of waves of electromagnetic energy, which would be light, X-ray, ultraviolet, infrared, and so forth. We have thermal energy, which is the results from the movement of atoms and molecules in a sample. So, for instance, if you have a baseball But inside the baseball, we actually have particles, and those particles are vibrating and rotating and moving in a linear way, and those the movements of the particles inside the ball would represent the thermal energy of that ball. The sound energy would be the fourth type. This results from the movement of waves of sound. And then we also have what I'm calling mechanical kinetic energy. This is sort of the macroscopic or large scale look at something like this. If we have that baseball again, rather than looking at the particles inside of it, we would be looking at the entire baseball moving through space. So this is due to the movement of large scale objects as they move around in our environment. Much of what you think of when you think of movement would be classified as this type, because it's easily seen. So why is energy important to us? We hear a lot about energy in the news media. One reason is that we need energy to be able to carry out the things that we do on an everyday basis, everyday normal tasks. When we're walking, we have to convert chemical energy from food into the mechanical energy that's going to move bones around. We have lighting of homes. We have to have electricity to do that, or candles or something of that nature. Refrigerators to refrigerate our food. Refrigerators don't work if they're not plugged in, and of course if they're plugged in, they're connected to the power grid, and there's some energy use involved in refrigerating our foods. Cell phones all have batteries. They have an energy source. Getting water from a source to your home, throughout the home, moving it from where water comes into the house to various locations such as bathrooms and kitchens in the home, or then moving it out of the home. You're flushing a toilet. You have water flowing down a drain. It's gravitational potential energy. Using a car to get to school or to work or on vacation. The list is endless of the ways that we use energy. We've always, as humans, been dependent upon energy, but we've really designed our worlds as engineers to use energy in unique, novel, and somewhat efficient ways. So in order to use energy, we design things that allow us to convert energy from one form to another. For instance, a simple machine is an energy transformer, especially if we have gear trains involved in it. We're moving energy from one place to another, and we're controlling how that energy is used. Another way, for instance, if we have a battery, the battery represents stored chemical potential energy due to the chemicals that are inside the battery. It doesn't do much if you just put it on a shelf by itself. But if you put the battery in a toy car, the car is going to convert the chemical potential into mechanical kinetic energy, and you've got moving parts, and the little toy car may be moving across the floor. So we design machines, and these could be compound machines that we're talking about, to utilize energy sources. A good portion of design, when it comes down to engineering machines, comes down to the efficient use of energy to help us do things. So to be useful, energy has to be transferable, and there are ways that we can transfer energy. Two that we'll deal with quite a bit in this course would be working, and notice that I've got this as a verb. Working is the transfer of energy by applying a force over a distance. We've talked about this quite a bit, actually, with simple machines, but we haven't necessarily dealt with the term work in great detail. Heating is another way. Heating is transfer of energy from an area of high temperature to one of low temperature. In fact, heat is what we call the energy that's transferred during that time. And we have an entire section on heat flow, which is called thermodynamics, in a little bit later section. So I'll leave that for later. All right. We can also define sources of energy, places that we get our energy, into several categories: non-renewable, renewable, and inexhaustible. The sun is the ultimate source of pretty much all the energy that's in these on this planet. So when we look at the non-renewable, renewable, and inexhaustible on Earth, they probably, in some form or fashion, originated in the sun. And there it is. Starting with non-renewable energy sources. Non-renewable energy sources are energy sources that cannot be replaced once they're used. Examples of this would include fossil fuels such as coal and oil and natural gas. In fact, anytime we have, these are such important fuels to our society that we call an alternative energy source anything that's not identified as a fossil fuel. Another example of a non-renewable energy source is nuclear in the form of uranium. Uranium has to be mined from the earth, and there is, as far as we know, a limited supply on the planet, and it's not being regenerated as we use it. It's converted into something else. So nuclear energy in the form of fission, which supplies 20% of the world's electricity, more in some places than others. We used to use a lot, and we seem to be moving back in that direction in the United States. France is probably the world's leader in nuclear energy use for domestic use. Renewable energy sources are sources of energy that can be replaced once they're used. For example, here we've got a dog sled and a team of dogs pulling it, so animals would represent a renewable energy source. If an animal dies, we have hopefully more animals generating more animals through reproduction. Food, which is as long as we're able to grow food, although this is a problem in some areas. Same thing here. Certain areas of the world didn't develop industrially the way others did, primarily because of the availability of animals that could be domesticated and used as energy sources. Food is another problem. This is a problem in deserts. We don't have large amounts of people in deserts generally because they have to import their food. Very expensive. So there's a limited supply to be used for whatever needs that we have. Biomass, which would be just biological material, this would include things like corn and certain grasses that can be converted into burnable fuels such as ethanol and methanol. It's very common to find ethanol mixed into gasoline these days to stretch it, and some say it maybe provides some benefits, but there are also some potential hazards to it as well as far as your car is concerned. And then we have those wonderful sources of energy that are somewhat inexhaustible, meaning that they don't have to be replenished. They're always there in large amounts with no end in sight as far as the foreseeable future. Hydroelectric would be one of those. Here we've got a dam showing water passing through. And hydroelectric energy sources, we've got water stored high behind a dam. It flows downhill due to gravitational potential energy. As it does that, its flowing is transmitted to a turbine, which is going to turn. It's going to turn a generator, which generates electricity to send out through long-distance power lines through the power grid. Tidal energy can do the same thing as long as there's a large enough tide to provide a significant enough energy source. Geothermal is another example where water, for instance, is injected into the earth, and the heating of the earth is used to move water again. So you basically have a circulation of water and or steam, which is also, again, going to turn some sort of turbine more than likely and generate electricity. We have wind power, which in some parts of the world is pretty much there all the time. For instance, around the oceans in North Carolina right now, there's a lot of controversy over putting large windmills out at sea, and the thoughts of what it would do to the tourism industry there, like it is here, that's such a large part of our economy. But it's a clean, other than the structures, of course, it's a clean source of energy in certain areas where the wind flow patterns make it reliable. We also have solar, which is getting bigger and bigger. We have solar panels. We have a satellite that's powered by solar. We have a large solar collection farm here with a solar collection tower. This is PS10 and near Seville, I believe, in Spain. And that takes care of it. You'll have an assignment that's related to this to do a little more research than this is just sort of an introduction to get you thinking about things, and you'll do more individualized research or group research as we move through the next few days.